Hello everyone, I am Hussein and today's lecture is about the spontaneous and non-spontaneous process. The spontaneous process, also called as the feasible process, or we sometimes also call it as a probable process, is a kind of process which happens or proceeds spontaneously. That is, it happens on its own without intervention of any external agency. The spontaneous process normally doesn't occur at once or instantaneous, but they occur very slowly to quite fast. Thus, spontaneity gives no idea about the time taken to bring about the change. The another feature of the spontaneous process is that these processes tend to proceed until an equilibrium is achieved. Also, the spontaneous processes are not reversible on their own. That means that they need some external agency or an outside agency or a certain initiation for the reversible process to happen. Some of the examples of the spontaneous process are nitric oxide in the gaseous form. When reacts with the molecular oxygen in the gaseous form, it leads to the formation of a nitrogen dioxide. This process happens spontaneously on its own. Similarly, when sodium hydroxide combines with then hydrochloric acid in a neutralization reaction, it leads to the formation of a sodium chloride and water. This reaction is also a spontaneous reaction. In a similar manner, if we add a drop of ink to a beaker of water, the ink spreads spontaneously throughout the beaker, making the whole solution ink colored. Again, expansion of an ideal gas through a pinhole into a vacuum is a spontaneous process because there is no energy change in the system during this expansion. Also, when carbon monoxide combines with oxygen, it leads to the formation of carbon dioxide, and this process is also a spontaneous process. Next in this section, we will see what are the different driving forces for a spontaneous process. Driving force is a force which drives the reactants towards the products. In other words, driving force is responsible for the spontaneity of a process. There are two important factors which are involved in the driving force. One is called as the minimum energy requirement, that is to acquire a minimum energy state, and the another one is to acquire the maximum randomness state. Let's take them one by one. So first, there is always a tendency to acquire a minimum energy. Most of the changes or the spontaneous processes that happen in nature proceeding with a decrease in the potential energy. The decrease in potential energy means to acquire the minimum energy or more stability. In general, a state of higher energy is always less stable than that of a lower energy, which is more stable. These processes which take place in the direction of a lower energy, like this reaction, are mostly exothermic, wherein some energy is released. That is, they evolve the energy, because this negative sign indicates that an energy is evolved. So when these reactants, that is the hydrogen and the chloride, combine, they are less stable on the reactant side. However, when they form a product, they are more stable in nature, or the potential energy has decreased. So in this case, the potential energy is more in case of reactants, and the potential energy is less in case of the products, wherein it is more stable. However, there are some of the processes or spontaneous processes which are accompanied by an increase in energy, like the endothermic processes. As an example, we all know that water from liquid state can be converted to a steam, which is a gaseous in nature. This process always is an endothermic in nature because it requires energy for evaporation. So in case of converting water from liquid to a gaseous state, we need at least 44 kilojoule per mole energy. Similarly, there are other examples also wherein you can see that the process is an endothermic process. In short, we can say that the highly exothermic processes like this one, they are generally spontaneous in nature, but some endothermic processes are also spontaneous in nature. So this overall indicates that the lowering of energy or the lowering of potential energy or attainment of more stability is not the only criteria for the spontaneity. That's why we take another criteria into consideration, that is to acquire maximum randomness or disorder. The energy absorbed in the endothermic processes increases the kinetic energy of the product than the reactants. So kinetic energy of the products is more and the kinetic energy of the reactants is less. So the kinetic energy of products is going to be more in this case, and it is going to be again more in this case. That means when water is converted from ice form, there is less kinetic energy involved because the molecules are intact, very close to each other. Whereas when water is converted into a liquid state, the kinetic energy of the molecules increases. That's why the water gets converted into a liquid state, and upon providing some more energy, the water is getting converted into a gaseous form, as we have seen in this case, that is 44 kilojoule per mole energy. The molecules in the water become more kinetic, or they attain more kinetic energy. In other words, I can say that there is greater randomness or more free movement as compared to the liquid state or as compared to the solid state of water. To conclude, we can say a spontaneous process can occur in a particular direction when there is an increase in the randomness of the species. However, randomness is also not the alone criterion for the spontaneity of the process. So neither the decrease in potential energy nor the increase in the randomness are the sole criterions for the spontaneity of the process. So both of them have to happen side by side. Now, since we have defined what are the spontaneous processes, there are some other processes which we call as the non-spontaneous processes. All the processes which are not spontaneous don't take place even by strong initiation. So even if you give a strong initiation to the process which is non-spontaneous in nature, it's not going to happen. For example, if we place a piece of gold in water, so this piece of gold does not dissolve in water. So this is a process which is a non-spontaneous process in nature. However, some non-spontaneous processes can still happen after providing them a strong initiation. For example, when we fill an overhead tank with water by using a pump so that the water gets to the overhead tank. So that's also an example of a non-spontaneous process wherein you need to give a very strong initiation. I think that pretty much concludes my lecture for the spontaneous process and the non-spontaneous process. I hope that you guys liked this lecture, and if you liked this lecture, then please subscribe to our channel and do share.